Well, ladies and gentlemen, welcome. We're going to begin now. So CSP, concentrated solar power, is a way to produce dispatchable or base load, if you like, solar power day and night, whenever it is that you need it, at a very good price, actually. As it turns out, you know, over the 6 gigawatts that we have installed, the price has come down some 70%. So it stands to reason that, you know, with deployment of the size of PV or wind, you know, the prices would get down to be beyond reasonable indeed. However, we do know that just because things make sense doesn't necessarily mean that markets work in such manners. And at times we're seeing markets that don't necessarily work the way that we would expect or hope for them. So in the case, for example, of South Africa and Southern Africa more generally, we have great direct normal irradiation, which means that the capacity for CSP is really high. However, it doesn't mean that, you know, the path is easy at times. So we're going to speak about what is going on with this technology in this region, and we're also going to speak about what does it mean, what's happening right now. The quarantines have meant that the energy demand has dropped considerably in most countries. So this has affected the spot prices, it's affected the energy market more generally. We've had minus $37 per barrel oil yesterday. This is in May futures, fair enough, but is it going to change anytime soon? We don't really know. It might get worse before it gets better. And then finally, we have the issue with the COVID. You know, banks have a lot of cash at the moment, but they don't want to spend it. There is a lot of uncertainty. So we're going to talk about all of this. I'd like to introduce you to the panelists, and I'd like to ask them to please introduce themselves just shortly, and then we'll go from there. So Trust, could you start, please? Could you introduce yourself?
Thank you very much, Belen. I'm Engineer Trust Ifamba. I'm an electrical engineer by training, 30 years experience. I ventured into renewable energy quite a bit late into my career, although of course, as you know, electrical engineering and renewable energy intersect in a very large way. So I then went on to do a master's in renewable energy on top of my BSc in electrical engineering. I did the master's at Heriot-Watt in Scotland, and I've been active in the energy space in Southern Africa, mainly South Africa and Zimbabwe, and countries in the region.
And you're based in Zimbabwe now, right?
Yes, right now I'm in Zimbabwe because of this lockdown.
Okay, so I'm locked down in Madrid as well, you guys. Madrid, Zimbabwe. Let's see. Tony, what about you? Tell us a little bit about you and where you're today.
Okay, so hello, Belen. So good to be back in one of the sessions. So I'm Tony Tiyu, CEO and founder of Renewables in Africa. So some of you hopefully will know us already. So where am I locked down into? So I'm in my home in London at the moment. So yeah, it'll be a pleasure to contribute. And just like Trust Ifamba, so I'm also an engineer by trade. So I started by mechanical automotive, where I worked for some time before moving and dedicating my professional life and life to renewables.
Am I a lucky girl or what? I get to hang out with engineers every day. This is amazing. Thank you very much, Tony, and welcome. And Pacho, last but not least, tell us a little bit about you and where you are today.
Thank you, Belen, and everybody online. Enjoying lockdown in South Africa, all good. In short, some of you know me. I'm the founder of Envelo, involved in a lot of CSP developments in the region with our primary focus in South Africa. And thanks for this conversation today.
Well, thank you and welcome everyone. I see we have people from many places in Africa and we also have a lot of Europeans, so welcome. I'd like to ask Tony, you're the first speaker, right? You have a presentation. If you can prepare it, and I'll just go through this really quickly, you guys. We're gonna do two presentations, Tony and Trust, then we'll have some words from Pancho as well, contextualizing this. And then we're gonna go into a little bit of a conversation because I think there is a lot to talk about with everything that is going on. When we plan these webinars, we certainly don't have now markets as usual. You know, we know already that we have issues to develop CSP in South Africa, but now, you know, the situation is somewhat more complicated. So Tony, have you got your presentation ready?
I do.
Yeah, just a reminder, while you prepare, we are recording this session and you will have the materials available. Go ahead, Tony.
Okay, so 1 second, I have it there, I can share.
Perfect.
Hopefully, can you see now?
I can, but you need to make that into a large presentation because we can still see the PowerPoint.
Okay, that's fine. Is that better now?
Yes, perfect.
Okay,
Go ahead.
No problem. So let me just make a quick start. So there's nothing to say here apart from the fact that those are nice pictures and show you what country we're going to be talking about. So I thought I'd start by giving a quick idea of what is the agenda we're going to cover, talking about renewables in Africa, the company, certainly, but understanding what is CSP, right? We talked a lot about CSP, but what is it exactly? Why is it important? Always very important to understand that. Obviously, having an idea of what is the status in South Africa, and potentially looking at the opportunities. After that, we will conclude. But first, obviously, we will talk about an event to everybody here. And I just want to take just a second to have a thought and acknowledge, obviously, the victim that's of the COVID-19 that's across the world. Whether you have one death or 1,000, it doesn't matter. It's still a life that we lost. So I just wanted to make that point. So moving swiftly into the presentation. So very quickly, what is renewables in Africa? So lots of you will know us already. We are a hybrid company, a two-in-one company. Why am I saying that? Simply because we are a clean energy engineering consultancy company providing project originations. Those are for developers, investors, project owner, but also market insight, just like we are doing today. But many of you will know us because we are Africa Clean Energy Champions. So we raise and promote renewable energy across the continent. And we do have a number of people we are working with, including some of our own staff. Our mission is very, very clear. It's about bringing back power to Africa. So very quickly, we've had a nice gentleman named Oluwochiwere who joined us. That's our regional director from Kenya, East Africa. The only reason I'm sharing that is because if he's reaching out to you, please be nice to him. He's a nice fellow. Okay, so I'm an engineer, so I like to go back to basics. So that's interesting because most of the time when people are referring to solar, it's solar PV. But CSP, what is it? In short, it's a solar plant that is using mirror to capture the sun's energy and convert it into the heat. What is quite interesting is that the solar CSP plant can actually be divided in two sections. You have the solar island. This is where you capture the suns with those mirror and capture the heat that you send to a steam engine that's in the power island. And with the steam, you will power a generator and produce your electricity. It's no different than coal, gas, and nuke power plant for the power island. That gives you an idea of what the solar CSP is. That's just a reminder. So they generally, four types we talk about. For just for time, I'm just going to briefly mention two of them, which is the most, I wouldn't say famous, the most used is the Parabolic Trough. This is where you have, like the name is saying, the parabolic mirror that captures the sun's energy and then reflect that into the main receiver pipe that is there. And inside the receiver pipe, you have the high transfer fluid. That's the one that captures the heat and take it to the power side of the plant. And then you have the power tower or the central receiver. Why are we saying that? Because they are using heliostat. Those are the mirror. That's how you call the mirror here. That's reflecting the sun's energy, the sun's X-ray, direct that to a central receiver that sits on top of the tower. That's what we call it, power tower. And inside the tower, you still have your heat transfer fluid that you take into the power section. Those are how those type works. Now, this is just an image of how they look like in real life. I'm sure you can recognize in here the Node plant, which is the biggest solar CSP plant in Africa and I believe in the world, if I'm not wrong. So, why is solar CSP important? It's always important to come back and understand why we're actually talking about that. Because we know that solar, the difference with PV can be deployed in Africa everywhere because there is a sun. But it's not the case for CSP, or at least according to studies, for CSP to be economic, you need to be above 2,000 kilowatt hour meter square per year. That's what's needed. So you're talking about abundance of solar. Countries like Botswana, Namibia, South Africa, obviously, and North Africa. That's important. In terms of the market, so PV market is way bigger than CSP at this point in time. There's a factor of 20 between the two, right, easily. And we also know that in terms of the cost reduction, so the rate of reduction of PV, it's a lot higher, right? So you'll be thinking, but why at all are we actually talking about solar CSP? Why should we bother? So actually 2 words, thermal storage, because there's a lot of, let's say, complaint regarding the variability, the intermittency. Solar CSP does not suffer from that. You can see in the image here, for example, those huge tower, that's molten salt, which is the fluid that is used to capture the heat. You can see, for example, where they store, right? So, and then you take it to the power sector. That's why CSP is actually particularly important, especially at this point in time. And just to illustrate that a little bit for you, if you're taking 100 megawatt CSP plant and you give it, for example, 12-hour storage, you can store up to 1,200 megawatt hour. And if you compare that, the same 100 megawatt power plant, but you want to associate a battery, right? So from current technology, you could about store something like 129. So there's factor of about 10 between the two. So you can see it's a massive difference. So obviously when it becomes then critical, it's what is the cost of this storage. If we're looking at data that Arena has put together, right, comparing the cost of storage in 2016, the cost of storage, where it's going in 2030. So what we can see, obviously, it's going to come down, but we believe that we can come down to maybe $150 per kilowatt hour. So that's what you will need. So CSP doesn't give you that inconvenience. CSP nowadays come directly with storage. So that's what is particularly important. Now, we're here to talk about South Africa, the market there. So what we know is South Africa has launched a very successful procurement program, so RIPPP. So there's more than 6 gigawatt that has been procured, more than 90 IPPs. Most of it is solar and wind. You can see across the 4 windows that have been developed so far, what is the distribution. What is very interesting to see is there is already operational solar CSP. Or if there wasn't, I'm sure Belen wouldn't have us here for the session. So what are those plans? So I've listed them here. So you have altogether 8, that's what I've counted, and 5 are currently operational. You can see the names here, Bokpo, Katu, Solar, and so on and so forth. So I think you can have more information very quickly on that. So if I can just stop sharing that and just share
you came out of
very
the
quickly.
oh, okay.
Don't worry.
That is not definitely not up to date. I've seen a few changes, but never mind.
Yeah, no problem. You can see, right?
Yeah, we can see.
That's fine. That I was just showing very quickly because last year what we did, we put together a solar tracker, Renewables in Africa, capturing all the solar projects in the continent, that utility scale. So you can see some of those solar CSP plants here with some more information with regard, for example, who are the developer, the EPC, the investment, so on and so forth. So obviously we have more information like that's accessible to people. Let me come back to my screen. Yeah, go back to the presentation so that Belen will not be mad at me. So there we go. So I think we're back here. Yeah, we're all back. Great. So that I've already mentioned to you. The cost came down to about 1.69 rand. That was for round 3. So the equivalent, as you can see in dollar terms today, 9 cents. So hopefully that's right. So I'm sure Engineer Trust and Pancho can correct me if I'm making any mistake here. So moving swiftly, the cost definitely for CSP is coming down, and Belen as well refer to it. And we estimate that, by 2030, we can bring it down even by half, 2030, that would be good. So with all that you have seen, so we will reasonably think that solar CSP should play a major role or a key role in the energy mix in South Africa, isn't it? That's what we would think. South Africa, like any responsible country, has an NDP, which is the National Development Plan, which is nothing but a vision of where to see the country going in 2030. Electricity is a key element, and they principally develop the demand forecasts. You know, they looking at a set of criteria where we have like the least cost electricity supply, the balance of the demand, and also security and the environment. And the way they model it, they've looked at different scenarios as to where growth is going. It goes from low to upper. Upper will be 4%. Low, I would say, I don't know whether they took into account a COVID situation. I'm not sure. I don't think so. Suffice to say that the RIP plan, so that was initially delivered, or the first version was in 2010. That was promulgated in 2011. Then you had a revision in 2016, and I don't know if it was approved, but it was a revision. 2018, that's the last that we had. There was a number of consultations that came around, but clearly one thing that was important is to make sure that there is a limit for renewable energy, because you also need to think about the integrations of this power into the national grid. So the RIP plan is a very central document, very, very important. So finally, the government issued in October 2019 the current plan, which obviously what everybody is referring to. So we can clearly see there's going to be no addition by 2030, right? We're going to have 6 gigawatts of solar PV, that's great, perfect. 14 gigawatts of wind, excellent. But what is actually quite, I would say, rather shocking is that there is no new CSP. So that is planned, apart from the 300 that's already been built and the one that is in construction and development at the moment. So the question is, where do you find your opportunities? So clearly, if you look at this plan, I don't think it's coming from there. Maybe on a private level, but clearly not on the national plan. So the good news is, if you're looking at the region, so you expand, you go out from South Africa, you're looking at SADC, Southern Africa. So there's two countries, two neighboring countries, Botswana and Namibia, currently working on a mega project. That's a 5 gigawatt solar project with the backing of people like World Bank, IFC, AFDB. You can read the rest. And both are going to include CSP and PV. It's going to be split in 3 phases, as far as I know at the moment. You're going to have a domestic, which you always start at home, developing a 300 to 500 megawatts of solar. Then you move into the regional. That's where you're tapping into the SADC market or the Southern Africa Power Pool, and then expanding it even further, going to East Africa Power Pool. So we will argue for investors and developers in CSP, that's an initiative that they should be looking at very carefully. But the good thing is, that's not all. I think there's a lot more talk now about also small solar CSP. I have in picture here one solution that is currently available in Morocco, right? Where they're developing the solar CSP, maybe for smaller businesses or residential, or potentially going to upgrade location. That's something people should also be thinking about. And I can definitely say at this precise moment in time, so we've kicked up discussion with a startup, I can't mention the name at the moment, but still confidential, who is developing a micro CSP plan. So basically, power plant that will be 10 times smaller than what it is at the moment. And we're talking about potentially piloting that in Southern Africa sometime this year. So let's see if COVID let us do that. So I'm just going to conclude, because we have other 2 fantastic speakers that will be addressing you today. Just saying that clearly the thermal storage for CSP give you an answer for the variability and the intermittency. So that's good for you to know. South Africa, it's a major market in Africa for CSP. They already built 300 megawatts. There's about the same in the pipeline now that we're expecting. The RIP, the integrated plan for 2019, does not include CSP, but you can find opportunity across the border, Botswana, Namibia, and potentially South Africa. If you're looking at a small CSP, why not? That's a way as well to get out of mapping to others. And one thing I would say, we're all talking about COVID, we all obviously bearing the brand of what is happening. It's definitely shaking and reshaping our society, our economies, and industry. But but as you know, when we're talking about those crises, we're also talking about opportunities. So everybody should be looking out for opportunities, and maybe there are some for CSP. All that to say, thank you very much. In my language, we say Ngopelo. So that's it for me.
Thank you very much, Ngupelo. I'm not sure I said it properly, but I meant, I'm going to say gracias. Trust, I'm going to ask you please to unmute your microphone and share your screen as well for the next presentation. I've been answering some of the questions as well. There's a lot of questions about cost and cost comparisons to PV and storage. Boy, are we going to have a good time answering questions right after this. It's going to be great. So is everything okay, Trust, or do you need help with anything? I've unmuted your microphone now.
Okay, thank you very much.
So Tony is giving a really good general idea, and I think definitely the Africa Power Pool and the fact that Southern Africa and other countries can generate is really interesting.
Yes, thank you very much, Berlin. Yes, I'm ready. So, right. So as my colleague Tony presented, there's CSP is matured as a technology, which now competes very well with other renewable energy technologies. Some of the slide information may intersect with what is already presented, so I'll skip through that fairly quickly. Right. So I'm trying to go through this one. Can you see my screen?
Yes, I can, and I can see your content page now.
Okay, you're right. So basically, we are a consortium of two companies called, that's what I'm representing at the moment in this webinar, Renewable Africa Zimbabwe, which I head, and E-Square Holdings, which is based in South Africa. So we got together to spearhead the rolling out and development of renewable energy technologies across Southern Africa and going into Africa. Right, who we are, RAS E-Square, we're an expert engineering firms in all power generation and energy systems. Our project experience spans the whole Southern Africa, Eastern and Central Africa regions. The expertise includes design and delivery of energy and water projects for utilities, governments, municipalities, and the private sector. We are actually actively pursuing renewable energy power lease agreements opportunities in the commercial and industrial sector, particularly in South Africa and Zimbabwe at the moment. We are backed by private equity and continental funders. Now, going on to the opportunities for CSP in South Africa, as alluded to by the previous presenter, Tony, CSP is now a well-developed technology globally since the mid-90s when it made its debut in the United States of America. So in that time, the technology has matured greatly and the costs have also come down and become competitive. But I must add that, as my colleague indicated, the cost performance of solar PV is still much better than CSP. The trajectory is the same, but solar PV has plunged in prices much faster than. So the two main technologies that we are focusing on in the case of South Africa are the power tower and the parabolic trough technologies, which again my colleague explained technically. But parabolic is dominated between the two of them. South Africa has 5 operational CSP plants, as you might recall from the slide that was shown, and 2 major ones under construction, and several ones are in the planning stage. The renewable energy industry public power procurement program has been the entry point for most of these projects, which started in the early 2010s. So in the last 10 years, around 1, 2, 3, 4. So that table, which also my colleague had a similar one, summarizes what is currently happening in South Africa. So as you can see on the extreme column there, 5 of the sites are actually operational, 2 of them are under construction, and 1 is in planning stage, with a total capacity of 700 megawatts when all of them are operational. As you can see, the Parabolic Trough dominates, as I indicated. There's 5 of them there, and 3 are power tower projects. Now, as I alluded to, the REI Quad P structure and CSP evolution in South Africa is what we're going to talk about now briefly. This public procurement program allows independent power producers to submit competitive bids to design, develop, and operate large-scale energy plants across South Africa. So this was done to regulate the sector, because obviously you cannot have anybody say we want to be licensed to develop 100 megawatts in Upton Park, another one saying this without any form of control. So they set up the REI PPP structure to try and control the development of the renewable energy sector. And so far, there have been 4 rounds, 1, 2, 3, 4. The first 3 have included a bit of CSP, which, if you may remember in the previous slide, is talking about the plants that are already operational now, which we'll talk about in a little bit more detail further on. But sadly, CSP is not caught up to where it should be in the latest round, which was round 4. And round 5 is planned due to excessive load shedding that is currently being experienced in South Africa. So therefore, CSP has a chance to catch up. Again, as we are all aware, we had the seismic change in the way business is done, brought about by the coronavirus, COVID-19. So that has had the effect of dimming demand, because a lot of industries are shut down. Commercial space demand on the grid has been reduced. So there's a lot of uncharted territory that we are venturing into at the moment. We don't really know how demand is gonna develop in the next year or 2. So a lot of these plans may actually be shelved because the demand is dipped. Again, we all wait to see what happens in the next few months. Right. So just to mention that CSP, based on the central tower, which my colleague explained in some detail, is experiencing a rebirth. So it is catching up. And in South Africa, as you might remember from the previous slide, there are 3 structures. 2 are operational for the tower technology, which are basically an improvement of where the technology has been implemented in Spain, for example, and in the US, but with improvements. So this technology is still on a steep learning curve. The REIPP has had various problems with tariffs that were awarded in previous rounds, having to be renegotiated downwards, because obviously, as you will appreciate, the cost of technology has come down significantly, especially solar PV. So a tariff that may have been awarded equivalent to $120 per megawatt hour may no longer be justified based on the new price, the new build price. So there's a lot of negotiations to revisit these, but the negotiations have also been sweetened by extending the tenure of the projects, so that the developers of the projects do not feel hard done by the decision to negotiate the tariff down, because they're being given extended tenure of the project. So when they were left, for example, with only 10 years of power purchase agreements, these have been extended in the negotiations. Some projects have yielded less energy than planned or than expected. Those are some of the problems that the RE Quad P has faced. Also, let's not be politically correct here. The fossil fuel lobby has also resisted the expansion of CSP in South Africa, the coal in particular lobby. So those are some of the issues which we'll go into in a bit more detail in the following slides. So this slide explains the challenges of CSP adoption in South Africa. So we can basically summarize them in terms of cost and funding, and then market and political will. The third one is technology. And then the last one is different rules needed for PV and CSP. So these are both solar technologies, the one being for solar panels and the other one for the heat transfer technologies. So going to the first one, the cost and funding. There is a wide gap that exists between the design stage and the manufacturing stage due to the learning curve aspect that I talked about. So you can see that because it's still an evolving technology, what is probably given as the costs at design stage and what is actually experienced when the construction is done are very different. So that has created a challenge in wider adoption. The second one is private financial institutions. They rarely finance developing technologies as they have not been tested over time. So the investment in CSP for that reason is regarded as high risk. So to mitigate that reluctance to participate in financing, syndication has had to be done in some of the projects, like the Kachu Solar 1 and Key, which had to bring together Abengoa of Spain, international CSP developer, the Industrial Development Corporation, and the local South Africa Community Trust Fund. So we go to the market and political will. The production cost of the operational Kachu power plant is about 22 US cents per kilowatt hour, while the average price for Eskom, the retail price of electricity, is about 8 cents per kilowatt hour. So as you can see, the production cost of the CSP plant is about 2.5 times the costs of electricity on the Eskom network. So the CSP production has had to be subsidized to be absorbed competitively. The clean energy comes at a cost, and thus there has to be, the market has to be massaged so that it accepts this higher cost clean technology for the good of the technology and for the good of society, so that the technology is given a chance to evolve and become cost competitive. I will just add at this point that these prices, in fact, some of the rounds that have been bid internationally for CSP have seen the production costs actually come down to something like $60 US dollars per megawatt hour, which is 6 cents. So the situation is actually going in the right direction. The need for the political will, political persuasion, and the market to be persuaded to accept CSP is actually reducing because the prices are actually coming down. Now, in the case of South Africa, a two-tier tariff system has had to be enacted through the program to make CSP competitive. For example, a base tariff is given as 14 cents per kilowatt hour, which is the same as $140 per megawatt hour. And the peak tariff given is awarded as 38 cents per kilowatt hour. In other words, when CSP is dispatched, during peak periods, like late afternoon into early evening, the producer of the power is given a higher tariff. And so you see that the question of storage becomes key there. Now, there are also technological challenges that have been affecting the rollout of CSP in South Africa. There are no local capacity. There are no local companies with enough capacity to develop CSP technology. Therefore, there has to be skills technology transfer embedded in the projects to develop local capacity. As referred to again there, another technological challenge is storage. More hours beyond sunshine are needed to make the plants truly baseload. In other words, for the power to be availed when it is most needed, there has to be more storage. And this obviously increases the production cost per kilowatt hour because the capex goes up. R&D, research and development, is needed to continue to solve this issue. In other words, to make the storage component lower than what it currently is. The last challenge which CSP has been facing is the need to differentiate between solar PV and CSP. The program, the RIE Quad P, binds all renewable energy technologies, RETs, together. That is solar PV, CSP, wind, etc. As you may have seen in the slide that Tony presented, a lot of power in wind and solar PV has been brought online, much more than CSP, because they were all bunched together in the earlier rounds of the REI Quad P. And that clearly put CSP at a disadvantage, because on its curve, the developmental curve of CSP was still, and also the cost evolution was still quite high. So there is need to analyze and develop each renewable energy technology individually in order to maximize its potential. Right, so we continue with that point. There is need to have a different adoption framework for CSP. And the first step is to develop a comprehensive roadmap. Because CSP has got a different deployment strategy to solar PV, for example, and the market dynamics are different. So a one-size-fits-all approach has been detrimental to the growth of CSP in South Africa. So there is need to streamline the policy issues so that the concentrated solar power is nurtured to its full potential. There is need in that roadmap to streamline, in fact, to identify the most important factors that are limiting the adoption of CSP in South Africa. And then after that, an adoption model will be developed from countering those limiting factors. This is just a snapshot of an integrated resource plan that was issued in December 2019, which called, because there's a system supply gap of about 3,000 megawatts on the ESCOM network. So this IRP was calling for innovative, quick-to-market interventions that would generate within 12 months in order to mitigate that supply gap. So the point here is to say, because the supply gap is worsened, initially it was 2,000 megawatts, and during the post-COVID, or rather the pre-COVID months, it had crept up to 3 megawatts. That was around January, February this year. 3,000 megawatts shortfall on the network. So a call was made for players to come up with innovative solutions. And some of them that have been submitted include dispatching coal-fired power plants that had been mothballed, including as well relocating some of them from Europe where they've been switched off, And this would be tragic because if you consider that the world is moving to clean technology, we are moving backwards, resuscitating coal-fired power plants that had been mothballed simply because we've got a gap to cover. This clearly presents an opportunity for innovative renewable energy technologies that are quick to market to be brought in ahead of these polluting technologies. So this is the power supply gap in South Africa, which I've just referred to. Eskom has been implementing severe load shedding in the past year because of the 3,000 megawatt shortfall. That window closed in February 2020. This was already the few months that people were beginning to talk about coronavirus, COVID-19. But because very few credible bids to close that gap of 2,000 megawatts, the inquiry as we speak is still open for offers. So the opportunity, obviously, to design and build and commission a CSP power plant in 12 months is going to be a very big challenge. But the point is, it clearly shows an opportunity for CSP to come online, come on stream, to close that gap. So as you can see from this map, the western part of South Africa has got very, very high solar irradiation in the region of plus 2,000 kilowatts hour per square meter. And this whole area represents opportunities for CSP to be developed. And the transmission network evacuate this power to needed energy centers, load centers, for example, municipalities in Durban, Pretoria, that area where is, the red section is borders Namibia and Botswana. So
I trust we're losing you sometimes. Are you about to finish?
Shows that South Africa has got, yes, I'm
okay. It's because we're losing you sometimes.
about to finish. My internet connection is not very good. So this is the last, okay. So CSP opportunities in South Africa, these are the concluding points. The operational plants established in the last 5 years are performing very well, and they are contributing to the power in the country. CSP has a critical role in adding to the renewable energy mix in the generation portfolio.
Okay, I think we've lost trust there, or at least I can't hear him. So I'm just gonna, I'm not sure. Yeah, I think we've lost him. So I'm gonna ask, actually, Pancho, you are just talking, so could you just mute yourself and give us, so you've actually put together Ilanga, you know, you're the owner of Ilanga, so you know better than anyone, you know what's happening, you know better than anyone that those projects are actually operating very, very well. So, you know, give us your perspective, you know, how are things at the moment, what's happening, you know, with the latest in South Africa, and what did you hope for the future?
Belen, thanks a lot. Can you hear me?
Yes, we can hear you.
Okay, thanks a lot, and thanks to everyone online and for the opportunity to actually have a conversation in terms of what's going on in the world as a whole and in the mix of COVID. Thanks for the earlier two presentations. All I'll try and do is to share with you probably around three areas. One, around the technology as on the ground. Secondly, around the current IIP and perhaps what it means for the future. And thirdly, probably just to talk about the need to decarbonize the grid, regardless of what's going on. So look, around the technology, very clear that the commercial technologies from a CSP standpoint that are dominant in the South African landscape at the moment is predominantly parabolic trough. And that's really purely from the lender's perspective that, it was a proven technology. Commercially, the lenders were comfortable with really kind of like funding a parabolic trough technology. So what you have, it was already indicated earlier on, you have roughly, I think it's around 600 megawatts of actually operating projects. And out of that, around 550 megawatts of that is purely parabolic trough. There's a 50 megawatt steam tower that, out of the projects operating, it is actually struggling to operate to its design capacity. Then there is the 100 megawatt central tower, the Redstone project, that is still waiting for financial close, and how soon that will happen and when construction will happen, it's another story. But from a technology standpoint and what's on the ground is that, look, the CSP projects on the ground have been operating great. They are good for the grid, particularly in the evening, providing the evening peak power that is required from about 4:30 in the afternoon to around 9:30 in the evening. So yeah, technology, all great. And as Balen indicated, we do have a 100 megawatt project that came on stream in December of 2018 that is operating and everything is okay. And I think the great thing even now with COVID is that all the renewables, PV, wind, CSP, all the IPPs are regarded as essential service providers. So those projects are currently producing in the mix of this crisis, but as already alluded to, there has been obviously a reduction in power consumption from the wider consumer because of COVID. But because most of the PPAs are on a take and pay, it means most of the projects are actually able to deploy what's required to the grid. I think for me, when we talk about technology, and there was a discussion around comparison around price of PV, price of CSP, and the colleagues also indicated that, at the end of the day, you have to look at those things, I think, how you compare apples and oranges, or how you compare oranges to oranges. And I think the value proposition for CSP technology has not been fully understood. And I think one of the things that I can just summarize in terms of what Trust was talking about is that when the REAP program, the procurement framework in South Africa started around 2011, the price of CSP and the price of PV and the bid tariffs that you could bid was both identical, was both the same. And when you look at it at that point in time, if I may also say, the initial procurement framework that was put in place before the actual IIP 2010 was approved, there was more CSP than PV in the initial plan. When that plan was then revised, it was revised and demonstrated that there was more PV to come in because the country was building its two large coal-fired power plants, Madupi and Kusile. And the problem they realized was that those power plants could not come on stream early enough. So there was a huge allocation for the first, second, and third bid windows for PV, purely because the thinking was we need to get some megawatts that can come on stream quicker before the coal-fired power plants happen. As a result of that, there was a limited allocation for CSP of about 200 megawatts, But what it meant, because it was a competitive bidding process, the more allocation of PV and the more allocation of wind in the early rounds created that typical competitive nature in a competitive bidding program that allowed those two technologies to gain significant ground in the South African program. Because if you look at the first PV projects that were bid, they were even expensive than CSP in bid window 1. So the learning curve and the learning rates and how the tariff reduced for PV, it was purely because of the allocation. So again, if in my view, I always look at it and say, if CSP was given a fair chance in terms of a huge size allocation, things would have been different. So take a look as an example. There was bid window 4.5. That basically was an expedited bid window. And there was a huge chunk of CSP that was bid in 2015, 2016, and those projects had never seen the day of light. But what happened actually with that procurement framework, the price of CSP dipped close to 1 Rand 10, which when you look at what normal coal-fired power station was kind of like coming in at around 92 cents. So I am of the view that if we had continued with the framework that makes sense, then CSP would have ended up there. But to summarize on the technology, I think the missing link and the lack of understanding in the market is the value proposition of the technology, the ability of the technology to actually develop an industry in the context of the region from a localization standpoint. And thirdly, the ability of a recognition that, look, with CSP, there's more jobs that you can create per megawatt, which is something that's required in this part of the world. If I move on to the integrated resource plan for 2019, quite clearly, again, the missing link there is CSP doesn't factor in there. Why? Because in my view, part of the overnight capital costs that are actually used for each technology that is plugged into basically your modeling, whatever comes out is really driven by what is the cheapest cost of capital of each technology that I'm putting in. But if you look at the IIP that we've ended up with, it basically is an IIP that is also has been policy adjusted. It's been policy adjusted to accommodate even for coal, when other players are even struggling to get coal power plants funded. It's also policy adjusted to actually cater for gas. Because if you worked on the principle of the lowest cost from an LCOE, you would have probably found that, you know, both gas and coal wouldn't feature, but it was adjusted from a policy standpoint because I think the politicians felt that needed to be there. However, as Trust was indicating that there's this emergency procurement, the gap that exists, and that talks about all technologies. But again, the challenge is, what is the framework that is going to be required to actually procure that? In my humble view, as well, there's other people that are saying that going forward, because you might need base load, you need peaking power, you need mid-merit, maybe PV plus battery storage can play the peaking role. But the question I have when people throw that is to say, the modeling that has been done in the current IIP never looked at PV plus battery storage if you're working purely at cost. Because if you looked at that, then I think if we're looking at it, CSP would also been competitive and would have featured in the IIP 2019. The IIP, even when it looks at 2020 to 2030, it's meant to be reviewed every 2 years so that it becomes relevant. And hopefully that is the situation that at the end of the day, we should have an IIP that gets reviewed every 2 years in order to actually ensure that everything is relevant. And as Trust also indicated, if I may share, is that when you submit a bid for a project or when you look at the IIP, the cost for each technology used in the IIP, by the time you have bid window 5 and etc., the cost will be totally different from a CapEx standpoint that you used in your model. And that's why some of us have always said, you need to have an IRP that includes all technology. You only determine the price at the time of procurement, and procurement should be based on what is the solution I want, as opposed to looking and say, well, I've got PV here or CSP. If the solution is to say I need peaking power, then CSP with gas could actually participate in that role. If the procurement says I need baseload power, then the guys can come up with solutions, and they can give you the price that is relevant at the time of procurement, not a price that you had when you had your IRP done. For example, the IRP 2010 that we had, that only its life ended basically in 2019. That was based on pricing that was 2009. But if you look at each and every project that we have now in South Africa, in wind, PV, or CSP, when it's bid, the guys, when they bid, it's a totally different cost to what was used in the modeling of the IIP. So there's no linkages on that basis. And then lastly, which also talks to the point that Belen was saying, what's happening with the oil price and all this kind of stuff. For me, it's around the decarbonization of the grid. Is that, look, at the end of the day, the climate issue will remain relevant. And I think it is important, regardless of how the market for basically fossil fuels might be dropping, etc. I think for me it's very clear that the trajectory we have to decarbonize the grid. And I do not see how we can decarbonize the grid in South Africa without looking at all technologies, and particularly ensuring that the CSP can play a role around basically being a power or a utility approach where basically you have the ability of providing firm capacity to the grid. So in my humble view, I think about the decarbonization of the grid is that there's a huge role for CSP going forward. But I think a lot of it, developers, technology owners that believe in the technology have to do a lot of lobbying work to demonstrate to policymakers why there's a value for the technology, and particularly when you start to look also beyond the region. So I'll stop there, Belen.
Thank you very much. I have a question for all of you, and then we'll call it a day because it's a little bit late, but I do want to ask this question, and this is open for the three of you. How do you think current prices of oil, current COVID situation changes the, I don't know if the politics is the right thing, but the forces that move the market for the next, say, 1 to 2 years? Is it going to be good for us overall, bad for us overall? Just an understanding of, I know there is a lot of uncertainty, but how do you think it's going to play? You want to start, Pancho?
Look, I think obviously if I look at the context of South Africa, and then now I'll zoom in perhaps just briefly in the region. We are obviously in this COVID all in lockdown. We are waiting to see what government is going to come out with in the next few days in terms of what is the economic recovery package that's going to be put in place to deal with what has happened. In my humble view is that, look, I think CSP, renewables as a whole, as a sector, I think they have a huge role to play as part of the recovery program, because these are infrastructure projects that actually, for me, they're going to drive everyone towards a cleaner path. And I think there needs to be a role around that, in particular from an infrastructure standpoint. I think even when we have the situation now where people are consuming less power, it's purely because industries have been shut. And I think over time, even if we going back and opening up in stages, is that at the end of the day, when things start to open up and open up more, there's going to be a demand for electricity. If the strategy of the countries become to focus more on health, whether it's primary health services, etc., the reality is that whatever we do as human beings, there's two things that we need every day. You need to turn on the electricity, and you either need to turn on the tap for water. So my humble view is that when I look at it, I just think this is just because of what has happened, but I don't think the world is going to stay like this. There's going to be a transitioning. And I think what the key message I see is that, look, we cannot carry on with the business models of the past. If we're going to improve on the health of citizens so that we don't have another COVID, it also means that we need to make sure the planet is clean in order to deal with that. And from an energy standpoint, the renewables have a role to play.
Yeah, build back better, right? That's what they say.
Yep.
Trust, what about you? Just shortly so that we can finish. Sorry, let me take your mute. There, go on.
Okay, thank you, Belen. I think Pancho, his summary was perfect. He took the words rather out of my mouth, because post-COVID, definitely the universe is talking to mankind. This is my philosophical view. And business as usual cannot carry on where we are polluting the planet at will because of capitalist imperatives. So I believe in the long run, in the medium to long term, we are going to have a consensus to have a cleaner management of our planet. The biosphere is going to be cleaned up, and that means reduction of the pollutants that cause ill health. So in that medium to long term window, definitely renewables are going to become the preeminent energy generation technology. Those are my views.
Thank you very much, Trust. And last but certainly not least, Tony, what about you? Would you want to add?
Okay, let me just try and be brief as well and respond to your question. So you mentioned about what is the impact in the industry right now. So I have to say, for project, you can split that in three phases. You have in development, in construction, and operational. If you're operational, depending on what kind of contract you have, you might not be that effective, take or pay. In construction, certainly there's going to be some delay. In development, those are the ones most at risk, I would say. Now, in the future, I will sort of agree with what the other two speakers have said. If you look, for example, for RIP, this is looking at the demand for 20, 30 years. So we're looking at short-term period, what are 20, 30 years? We still need to fill that demand. And I'm just going to end up in saying that we need to fill that demand and also do that responsibly. And one thing that everybody forget, climate change is a global issue, and fossil fuel doesn't solve that global issue.
Yeah, thank you very much, all of you, for being here, Tony, Pancho, and Trust, and for sharing with us. I know at the moment there is so much uncertainty in the South African market. Well, there is uncertainty everywhere right now, but we do have to hope that if we're looking at infrastructure the last 25 years, if we're looking at strong grids that are there for us, we don't have to constantly invest, we can invest and then maintain, that is the right thing to do. Do it once, do it properly, and let it stay. So I hope that when we talk about 25 years, just a couple of years now dealing with COVID and all of the situation, really, like it pales in comparison, and that we can go back to actually thinking a little bit of things more in life cycles. So thank you very much, guys. And thank you everyone in the audience there, and I'll see you next time. So for now, I'd just like to say bye-bye and thanks. Bye.
Thank you.
Thank you. Bye-bye.
Bye-bye.